And then we can start with the session. Sorry, my voice is not 100% there yet. But we get it. Okay, so let's start the session. Um, as you can hear, the voice is not 100% yet, but slowly, surely we're getting there. Okay, so tonight we're gonna look at a recap of study unit 8 and 9. Um, again, this was not from this year's assignment. It was a previous last year's assignment that I took and looked at to get some feedback. So we're just going through that and to make sure that it's also part of the prep for your exams, but we will also redo a few of this later, just before you need to write. Okay, so the first two things, nearly, it's not about any of the questions. I just thought again it's important to bring the one tail and the two tail just because we're using it so much. So specifically in the confidence intervals, um, when we do hypothesis testing, and now also with a lot of the chat um, last day or two around the chi-square test and those kind of things, and do we use certain alphas and those kind of things. So I thought, let's just again, for a recap, look at for study unit 8 and 9, um, where we working with confidence intervals. We will always work with a two tail. Okay, so when we do confidence intervals, it will always be the two tails, because the easiest to nearly always show it is we're working every time within the confidence band. So that's why when we do confidence interval, we always work with a two tail. So, and then in study unit 9, when we look at hypothesis testing, there basically we can say, but depending on how the hypothesis is, we will all have a two test when the null hypothesis is equal, alternative is not equal. Not because not equal means that it might be smaller or it might be bigger. So that's why we will have a two tail. When it is directional, meaning that it wants us to work out all the bigger than or the smaller than, we work with a one tail. Okay, so that is the only time we will use the one tail is when we need to solve or a hypothesis. And that is also why in study unit 10, the chi-square, where we will also use the one tail, because that is also how it is structured, but because there always we test for independence and not independence. So again, that is why in chapter 10 with a chi-square, we also will always look at alpha divided by 2. Okay, so again, just important. So when we have two-tail, remember it's alpha divided by 2. So if we sit with a 95% confidence interval, the 95% will sit in the middle. On this side, there will be 2.5. And on this side, there will be 2.5%. If we work with a one tail, this part will be 95, and that will be your 5%. Or if we do it the other way around, the bigger component, obviously the 95, and then the smaller component will be your 5%. Okay, so I thought important just to show this again to you. Again, I will share the slides afterwards so that you can also see, and that's why I'm also going to just take some of these out again so that you can use this slide also for when to reject and not reject. So I thought that is also a very nice, easy one for you to have at hand when you need to make your decisions about the rejection area and not. Okay, so we will use this slide again later on because it's a very nice summary of the rejection areas and things like that. Okay, cool. Then the other thing, again, that I wanted to share is just some of the numbers. Again, this is from one of the tables within your study guide. And again, just that when we work with one tail and two tail, you don't need to go and search for numbers. We can use this table as a given. So when we work with two tail, we know that in this instance, two tail 95%. We know that we're working with a Z of 1,96. If it was a one tail with 95%, the Z will be 1,645. Okay, so again, nearly want to show that you can automatically, when you nearly get a question, automatically when it's 95 and two tail, you can write down Z is going to be 1,96. So when we do a confidence interval for the Z, you can automatically nearly say that. Okay, so let's get into the first question that I want us to look at. I was hoping it's a bit clearer, but basically what it says is, which of the following statements is incorrect? Then basically every time we get, when the sample size is 60, 95% confidence interval estimate for a population mean is this. When the sample size is 100, we get it. When the sample size is 200, when the sample size is 500, and then none of the above. Okay, so let's see if we can solve it. What do you guys think? So before we even, is there enough information for us in this to really tell if it will work or not? or do we need more information? And then I'm just writing down. Okay, so we normally will work with a confidence interval where we say x plus minus z standard deviation divided by square root of n. Okay, so if we keep everything similar and we decrease or increase this by increasing the n, this should decrease. Okay, so nothing in here. So basically, if we keep everything else as a given, and we move from, let's say, 60 to 100, so that will mean that the bottom component will become bigger. As that bottom component becomes bigger, I'm just now trying to think, as that becomes bigger, this component will become smaller. If that stays the same, it means that this component will become smaller. So as sample size increase, the confidence interval will become less. Okay, so that feels correct, but we still need at least information, a bit more information to tell us if we're starting off with the right one. So this is the first time I would, probably the first and last time, that I would pick none of the above. Because what this shows me is that the one with the smallest sample has the biggest gap, and the one with the largest sample has the smallest gap. So nothing in these can tell me that one of them is wrong. I just don't know all the other information around it. So that's why I would stick with option 5. What would you have done with this one if this was now an exam question? Because that is, so there's nothing in this that tells me, because all 4 of them can be correct. So nothing in this tells me that I can exclude any of those. So then I would rather say none of the above, because I actually don't know. Just see if there's anything else in here. Sample size. Yeah. are you guys in agreement, or what would you have decided on something different? Okay, so let's go to the next one. And okay, so what also might have been is that if I now look at it, it might have been a spillover question from a previous question as well, because if you look at question 4, it's actually now talking about the same thing I did now by looking at the increase in sample size. So let's look at this one. Assuming the level of significance stays the same, like we had in the previous question, the 95%, what happens to the confidence interval estimates when the sample size increases? Okay, so we had sample size increase. As sample size increase, the confidence interval becomes smaller. So as sample size increase, confidence interval estimate doesn't change. So that is definitely not. Confidence interval estimate becomes wider. It's actually the other way around. Confidence interval estimates becomes narrower. So this is also interesting. The confidence interval estimate converges to 0. Okay, so let's look at the previous one. So it doesn't converge to 0. What will happen, and I assumed here it was probably that your mean was 100. So what will happen is the bigger your sample size, the confidence interval estimate will convert to the mean. Okay, so if that was there, it would have been correct. So you can see in the previous question, the bigger the sample size, the closer it becomes, or the closer it becomes to the mean that you were looking for. And that is also, I think, what's important nearly when we look at samples and populations, and this is now actually a nice view of it, is the bigger your sample, the more likely is it that your sample is a very good representation of your population, and that's why your confidence interval will become so small with a bigger sample. Okay, so and it makes sense that if you had a population of 5,000 and suddenly you draw a sample of 500 of them, you will be much more likely to get a very good representation of that population than if you only draw a sample of 60. Okay, so what happens is that the confidence interval estimate become narrower, but the other thing that is important as well, if I ask it, it also means that you basically converge closer to the mean, not to 0, but to the mean. So if that is just an add-on, if you guys might get something like that ever in one of the papers. Okay, so now we go a bit into the calculation of the confidence interval. So first, let's highlight a few things. So let's just look. Took a random sample of 30 adults and found their reading time to be normally distributed. Sample mean, sample standard deviation. Okay, so if we have sample standard deviation, that is exactly the same to say your population standard deviation is not known. So if we have sample, we don't work with a Z, we work with a T value. If we're working with a T value, we need to get the degrees of freedom. And remember, we then work with alpha divided by 2. So that is the table that we will need to go look for, the T table, degrees of freedom, and alpha divided by 2. So degrees of freedom was, we calculate it is n minus 1. Let's just put that alpha as well. I'm sure, okay, there we're talking about the 99%. So alpha is 1 minus 99%. But remember, divided by 2. Okay, so we're going to work with T29 and 0,005. And let me just quickly get in my notes where my study guide is, so that I can bring that up. This is not cool. I find that. Where did I now say that? I'll be with you guys now to share it. Uh, okay. Okay, so just get to it. Okay, so we sit with a T. We said it is 29. And we said 0,005. Okay, so 29, 0,005. So it is 2,756. So that is 2,756. So then our confidence interval will be, and let's automatically write in what x is. So we sit with a sample mean of 90. plus minus your t value, 756, times, remember, your standard deviation divided by square root of n. Okay, so that is our formula. Let's quickly just check. So 90 will be in the middle. If I look at this, yes, both can be 90, so 80, 99 can be 81, 98. Okay, so there's none of these that by just looking at what I need to calculate can just eliminate, unfortunately. So we will need to work this out. So 18 divided by the square root of 30 is 3,2863. If I times that by 2.756, I get that this answer is 9.0571. And let's just hope there is a few. So if I add 90 to it, it will be 90,0571. Okay, so there at least. And if I subtract that from 90, I get 80,9429. Okay, which is then option 2. So very important in this instance that they tell us that we're working with a sample standard deviation. Because we're working with a sample standard deviation, we will be using a t value. Okay, and then t, remember how to calculate the values around that. It's the degrees of freedom, so n minus 1. And then also very important, alpha divided by 2. And remember, we're working with confidence interval. That is why we say alpha divided by 2. Okay, so that's when we would calculate this one. Okay, questions on this. It was interesting in this assignment that they started off with a T. Normally they ask you a Z first and then a proportion and then probably a T next to it, but I think you guys now saw it in this assignment as well. It was assignment 4. Again, where you also had, what was it, question 2, that gave a bit of issues, because I think that was also to do with a t distribution. So it's nearly in one's mindset that you need to get the Z first, then you need to get the T, and then you need to get the proportion. Okay, we can do Excel as well. I just need to quickly find the one that I shared with you guys. Okay, so let's. Okay, so you can see this one is. I see that. Let me just quickly make 100% sure. known. Let me just get the right one before I start. Okay, so let's quickly. Okay, so let's see if this can work. Gonna work with this component. My worry is just it might be. Let's just see. Okay, let's first see before I say my worry. So let's quickly see. Sample mean was, and just check that I'm using it correctly, was 90. Okay, so that automatically changes. My sample standard deviation was 18. Okay, so that was the 2. Sample size was 50. Okay, so that's fine because that's just how we're going to use it. Degrees of freedom. Okay, so that was okay, so let's just quickly check that should change to what was included. So here is the area where, so I'm gonna highlight what we are putting in, so that you guys, I'll then also share afterwards again with you so that you can just see how it was put in. So there's the 90, so the sample mean one, there's the 18, there's the 50 for N, your degrees of freedom is 29. So let's quickly, that should be not 0.1, it should be 0.005. So that is where we need to change, but also then, okay, so there it is. So let's quickly want to bring up this. Okay, so important, I'll get to the question now. So important when we work with this, and this is the, sometimes when it's the difficulty with Excel, is you need to put the alpha in. So I'm gonna add here a column or row that includes alpha, because that was the 0.01. Because you don't want to, and that should also, I'll get to your question now. So what I've done here now is to say, you need to put in your alpha as well. In Excel, it sees it as two-tail. So it will automatically take the alpha in that formula and divide it by 2. Okay, so you must please not in the formula, you must not still make that 0.0005, because then it nearly seeing it as 0.001 alpha. So Excel automatically already divides it by 2 for the two-tail. Okay, so I think that is the important one. So if we included those numbers, we included the critical value, the t-tail will then be calculated, and you can see then your upper and lower confidence interval was the same as the ones we had calculated now. Okay, so in here is also when it is known, and in here is also if you need to only work out certain values. Okay, there's a hand. You can ask. Yes, can you hear me? You can ask your question. Else we can continue, but Joannette, if I'm pronouncing your name correctly, does this help what I just showed on Excel? I think also it's important that in this document over Excel, there's lots of examples. So it might be that sometimes we just need to look for the correct one when we're doing these calculations.
Yes, John, thank you. But do we need then to change on the right side, or is it now automatically change?
It's automatic.
The
It's
0.00 or everything. So we can just put in the mean and the deviation and the sample size.
yeah. So what you need to put in is the ones that I now highlighted
Yes.
in gray. Yeah. So I will share this again later on the group so that you can just use that again.
Okay. So when we go on, then we can hopefully then the other ones, other sheets, that is correct because I did go through it.
Yes.
Okay.
Yes.
All right. Thank you so much.
Yeah, and I think on this one should actually hide some of when there's too much info. Sometimes hide the rest of the info as well. Because you can see as we were playing with it, there is sometimes too much, and then it becomes really confusing sometimes when you work with it as well. So what I would have done if I'm using this in the exam and do it now as as you prep as well, when I get this question and I see, okay, confidence where it is unknown, what I would just go and do is say, hide that, hide for other stuff. Let's focus now on this question. Just so that you don't get confused with all the information. So I'm going to use the same spreadsheet now for one or two of our other calculations as well, so that you can just again see. But I think what is very important with a spreadsheet is also, if you look at, and there you can see where I got that 1 and 2 tail. But again, suddenly there's a lot of information, but we might only work on the one component, then hide the rest as you work through the question. Okay, so let's then get to the next question. So the next question is, I thought was quite interesting. So in a random sample of 1,000 observations, we found the proportion of success to be 48%. The upper confidence limit for the 95% confidence interval for proportion is. Okay, so you only need to give the upper confidence. So, but remember, we're still working with a confidence interval. So there is a upper and a lower. So when we work with 95%, it is that we're still working with a two-tail. Okay, so still working with a two-tail. So the Z will be equal to 1,96. Don't now, because they only talked about upper confidence limit, think that, okay, we're working with a one tail because we only want the upper confidence limit. They just want that for you to replay that in the final answer, but confidence interval always has a lower and the upper. We just want now to work out what the upper is. Okay, so we will still use the same formula, but because it's proportion, we will work with a proportion formula. So let's quickly check if I have that in here as well. So let's just quickly see if we can make this a bit bigger. Okay, and things that they have given us. So the first thing that I think we can include here, so they don't give us, they give us the N. So they tell us that the sample size was 1,000. They didn't give us X, but they told us what that proportion was. And that proportion was 0.48. So in this instance, and that's, and okay, let's do that. Let's just put it in 0.48. Okay, so that was the second one. So that is two of the components. So now let's see what else. So that one can change back to 480, because that is how we will get to the 0.48. So they don't need to give you the X was 480. They basically gave you the proportion beforehand already. Okay, so let's just see on this where we need to work and look at. I just want to get to the right one. So this one was more to get if you want to work out with Z. Let's just make this bigger. Okay, so this one is where we're going to work out our lower and upper confidence interval. So again, we had 480. We had for 1000, we had that. They told us that we are working with 1.96. So this is for one, well, they told us 95%. So let's quickly check if we can. So what I want to do is we can put it down there for 1.96, but let's see if there is a function that we can include. I just want to check again. That was a T function. So will there be a Z? Let's see, Z inverse. Okay, there's only a okay. So I was looking now for. I will check if there's a function for that, but by using this 95%, the 1.96, and now you can see it did give us a lower. We only want the upper one, so 0.511. And if we look at the question set, there is the 0.51. Okay, so again, we could have done it here as well. Then it would have been exactly the same kind of calculation. So if you want, again, doesn't matter which option you want to use, if it is via Excel or if you want to calculate and use a calculator, exactly the same answer you will get. Okay. Is that a bit better showing how to use the Excel in this component as well? All these steps is just, and one you can even hide it. It was just to go step by step through all the different steps to so where is that now? So it was in calculating all of these. So one can probably hide that if you want, because that's not really that important. So that was the component where we said 0.48 times 0.52. That is the component where we divide it and square root, and then this is a component where we multiply by the 1.96. So if you want, you can actually hide those, because it is not needed for you to complete any of those. You just want to make sure, and let's rather do that. Because for you, you just want to put in the measurements that they give you. Sure to put in 1.96, and then you get your two limits. So if it is the lower or the upper. So let's make it like that. Let's also add this component, because again, it's not needed. You can use this table that is here. Then it is, you will not need to work out the Z of a 794 level. So the Z's that you guys will need to use are the ones that are on this small table. You will not need to use any other Z, so you don't even need to worry about that. So with both the mean and the proportion, the Z's will always be for 99, 95, and 90%. Okay. Hope that helped. Let's check the next question, unless there's a question. Okay, so the next one, we're going to do a hypothesis test. So which of following statements is incorrect? Okay, so let's first look at null hypothesis equal alternative hypothesis is one directional. So if it is one directional, it is one tail. Okay, so it's showing us one direction, so it is one tail. So unfortunately, we need to get the incorrect one, so it's not that. Let's see what else is in here. 5% level. So remember, 5% level, one tail. So our Z is 1.645. Remember, one tail, 5% Z. Your critical value is 1.645. Okay, so I haven't calculated anything yet. Just by using this table and the direction, we already got two answers. Okay, then they ask us to work out the standard error. Okay, that we'll do. Then they ask us to work out the test statistic. So that we will also do, and we can see if we can use Excel, and when they ask us to work out the p-value. So let's first go to the spreadsheet and let's see what is in here. Okay, so we have a bit of information, very small at the moment, but we can fill in information. So let's first, before we get there, get a few things that we've done in chapters 6 and 7. We've done the standard error. So remember, standard error is this part of that Z component. So we know that the pi is 0.4. So we will multiply that by 0.6. And if we divide that by the sample size, which is 49, that we will get an answer. Let's quickly check in here. So in here, there wasn't a standard error, or there it was actually. Well, that's the total one. So because the standard error is not really part of hypothesis testing, it doesn't really feature, but let's quickly make sure that we cover that in here as well, because it is part of this formula. So let's put it in. Okay, so let's quickly see the information. Level of significance. Okay, that was given to us. It's the 0.05. We don't know the number, so here it now becomes that we rather populate this one. So I'm gonna make that, black that out, because we know what that is 0.4, so that it can be used across the board. The sample size was 49. Okay, so let's quickly check what else. The sample proportion was 0.49 or 45. So again, that was things that we actually needed to put in. And so if we need to calculate the Z, we will be able to do that. Let's just check what else. Standard error, let's put that into the formula for you guys. It is the square root. Okay, let's just make 100% sure, and let's round that off. Sorry, wrong presentation. So standard error is 0,007. Okay, standard error is, and let's win, is actually 0,07 and not 0,007. Okay, so that one was the incorrect one. But let's further add, so that was standard error. Okay, so that is, okay, sorry, so there it was actually done. So we can keep it. Then if we look at the test statistic, so what is very important here, and let's quickly check. So I swapped those two around. Let's just see if there's actually a difference. So that's correct. That's correct. If we round it, let's just make it round off. Okay, the t-stat was calculated 0,714. Let's also round it off a bit. So if we look at the t-stat 0,7143, sure, 7144. So that is spot on. So that would have also been incorrect. And then a p-value. So let's quickly, so if you then look at, there's a way that we would have gone to the table. So with that 0,71, we would have said, okay, remember what we did in chapter 6. So we would have gone, here is a 0,71, yeah, 71. This part is the p-value. That would have been the p-value. So we would have gone to the table. We will get this part in the Z table. Then we will subtract 1 from it to get that p-value. So let's do it that way. So it was 0,71, which was 0,7611. 0,7611. So 1 minus 0,7611 is the p-value. And that is 0,2389. Okay. So what is in this as well? Yeah, your p-value was calculated by using the built-in function within Excel. So again, there we have it. I'm gonna, again, let's just take out some of these extra things that makes it a bit unclear. So there was the p-value that we were looking at. Okay, so if I look at what is in this now for you to use, there was the t-stat, there was the p-value, there is the standard of error. So most of it is now in here, and then it will work out. If you needed to get more information, you can see everything in this question was covered, except the one tail that we can't build into Excel. But that's easy enough to see that from your hypothesis, and the critical value is easy enough to get that from your table. So it might be that we can just again include the table here if needed. Okay, so that was when, if we need to work out your hypothesis testing, and you want to use the Excel component. Okay, so, and you saw that doesn't matter if we use Excel, if we use the normal formulas, if we use the tables, we will get the same answer sets. Okay, what I have included as well is just a bit of the calculations behind each of those ones of A2 or 1 to 5 and how it was calculated, so that you guys can also see that. Okay, so next one. So read through it, tell me what you would have done in this instance. Will you use one tail, two tail? Yeah, so what would you guys do? And then if we have all of this information, how do we then work out the p-value? Okay, so look at the question, jot down a few things, and then I'll show you what we can do. Okay, cool. So we need to work out the p-value. So for that, we will need to work out nearly what is the t-stat that we're going to use. Because if we get the t-stat, we can go to the Z table, and then we can get that value that we want to get from that Z table, so that we can get the p-value. Okay, so that's nearly how we want to get to it. So that brings us back to how do we then calculate the t-stat. So this t-stat component we've done in study unit 7, and it is now also in study unit 9. So we need to remember this formula. again, and remember the component below the line, that is also the standard error. Okay, so we would have used that. So let's quickly check if we can use this. So the sample size was 200. The P divided by N, so X divided by N was, and that was in this instance 88 divided by 200. It was 0.44. We tested, so let's quickly go back. So that was for 88, that was for 200. We got it that we need to test against 0.4. Okay, so the 0.4 stays the same for this one. Okay, so when we start working with the top of that equation, that would have been then the 0.44 minus 0.4. So let's just make sure so that we cover nearly both components. Okay, so that's sorted. Standard errors, so below the line is 0.0346. So below the line, 0.0. Let me just check again. 0.0346, 0.0346. Okay, so when we divide that into that, we will get around 1.1561. Okay, that's the t-stat. It was actually an option there, but we're not working out the, we need to work out what the p-value is. So just again, in the exam, very much easy to now have said, I've got, it looks like I've got the answer because it is there, but we need to get to a p-value. Also remember, you can't get a probability that's bigger than 1. So that option definitely not one of the options. Okay, so but we've got the stat component, and then actually if we use the built-in function of Excel, we got that our p-value for the one tail is the 0.01 or 0.12, and for two tail is 0.24. Okay, so remember, now let's go to the Z table and let's just see if we got the same. So t-stat 1.156, so we need to round that off because our Z table only goes to 2 decimals. So 1.16, 1.16, so we get the 0.877. This component is 0.123. Okay, 0.123. But one or two tail. Are we working with a one tail or a two tail?
Two tail.
Okay, perfect. Working with a two tail, what we've done here is we only calculated it for the one component. So in actual fact, there's also a component just as big as that. So we need to add the two together, which will give us the 0,246, which then actually gives us option 2. So unfortunately, if you only stopped at the t-test, there's the answer. If you stopped at the one tail, there's the answer. And then there's the correct answer for the two tail as well. This is probably the most difficult it will get for you in my hypothesis testing, because you needed to work out if you're going to use the one tail or the two tail. You needed to work out with the proportion with t-stat. So this is probably going to be the most difficult you'll get for the hypothesis testing. Okay. Again, I have included for you guys some of the calculations, again, how to get to it, but also you can use this component within Excel. Just make sure, and let's just add it here, that if you use Excel, that just make sure that you use the component of a one tail or a two tail correctly. Okay. Because how I would probably do this is I would still draw this diagram for me, so that I can see. Doesn't matter if I get to Excel and I get to that value, because that I would have just substituted in here as well, even if I didn't use the table. But still, this shows me that if I only looked and used the 0,123, I actually only used it for the one tail. So I like to draw these small diagrams just that I don't nearly forget, because again, being in that situation in the exam, one is stressed, one see a number that is exactly the same number as you have on your calculator or Excel, and one just very simple can make that mistake. Okay, the last one for this recap nearly is a bit different. So they're giving you a lot of information, way too much. So they're giving you information around the hypothesis testing, but actually they just want you to write down what is the null hypothesis and what is the alternative hypothesis. So again, what is important in your exams is they like to give you sometimes more information than less. So they didn't need to give you all of this. So let's quickly check what we need to really work out. Okay, so random sample of 10 public swimming pools, blah, 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 blah. The sample mean for this random sample, X is equal to 0.3 with a standard deviation of 0.15. The claim made by the swimming pool administrator is that the pH value of public swimming pools is greater than 7.5. Okay, so greater than 7.5. The null and alternative hypothesis may be formulated as follows. Okay, so your null hypothesis will say, oh, it's not greater than 7.5, it is equal to 7.5. Okay, so your null hypothesis will say it is equal. Your alternative hypothesis will say it is greater than 7.5. Okay, so let's see equal, greater, so it can be option 1. Equal, greater can be option 2. Equal, smaller, not that. Equal, smaller, not that. Equal or equal to, smaller than, not that. Okay, so now the question is, which one between 1 and 2? So what would you have said? Which one is the correct one?
Number 2.
Okay, perfect. Because
Of the mu.
exactly, we're looking at the mean or the mu. How we pronounce it. We will never have that. So we will never look at a random sample. That is not the one that we're gonna reflect. So it will never be that. It's always the mu or the mean or how we pronounce it. Okay, so sometimes what they could have done in here as well is to bring in the 7.3 so that it just makes it a bit more difficult, but a lot of information in here. They could have just had nearly this last part by saying the swimming pool administrator is that pH value is greater than 7.5. But they gave you a lot of information, and it's not needed. So just be careful sometimes when I give too much, that there might just be a simple answer in it as well. Okay, cool. So this was nearly a quick recap of study unit 8 and 9. We'll go through it again in about a week's time, a week and a half's time before you write the exam in any case. So this will not be the end of this. So let's just take a few minutes. We've got another half an hour. I want to continue nearly with that other big pack as well, that we do a bit on study unit 4. So I'm gonna stop this recording so that I can also put both recordings for you on the